Welcome to Networks Professionals.
We live our lives in this world that feels completely wireless, totally instant. It's almost magical, right? But behind every single click, every stream, every app, there's a very real, very physical world of blinking lights and literally thousands of miles of cable. So today, we're going to trace the incredible physical journey your data takes, all in the blink of an eye. No, really, stop and think about it for a second. You click a link, and a page from maybe halfway around the world just appears on your screen. What physically just happened? What machine's word to life? Where did your click actually go? Well, that's the journey we're taking right now. Okay, let's dive right in. Our journey doesn't start in some huge, far-off data center. Nope, it starts right where you are, with the hardware that's closest to you, the stuff that connects your computer to the outside world. This is the first and absolutely crucial leg of the trip. All right, so the very first piece of hardware your click even talks to is the network interface card, or NIC, inside your computer. This is the official starting gate. It's the device that has the job of translating the purely digital command of your click into actual physical electrical signals that can travel down a wire. And just like that, that signal is on the move. Now, if you're on Wi-Fi, it zips through the air as a radio wave to a wireless access point. But whether it travels through the air or through a physical cable, that signal is heading to the exact same place, the local traffic director we call a switch. Think of the switch as the mailroom clerk for your local network. Your home or your office, that's one building. The switch knows every single device inside that building, your laptop, your printer, your phone, and its job is to make sure a piece of data meant for one device gets delivered to the right desk, and it does it instantly. And this is a really important difference to get. A switch only handles local traffic, just like that mailroom clerk who only delivers mail inside their own building. But your click isn't for someone else in your office. It needs to go out into the wider world. And for that, it has to be handed off to the city's main post office of the network. So our little data packet has now been sorted by the local switch. It's basically standing at the front door of the building, ready to head out onto the vast superhighway of the internet. And that gateway? Well, that's the router. The router is the main post office. It doesn't really care about the local desk locations. It looks at the global street address, the IP address of where your click needs to go. Its whole job is to figure out the fastest, most efficient path to send your data across the world. Without it, your network would just be an isolated island, completely unable to talk to anyone else. But wait, before that packet can officially leave, it has to get through a security check. And that is the job of the firewall. This thing is the network's bouncer, the security guard, standing at the main entrance. It inspects every single piece of data that tries to come in or go out, making sure it's not dangerous and that it's following all the rules. It's an absolutely critical layer of defense. Okay, so our click made it. It passed security, it's been routed across the internet, and it has finally arrived at its destination. But where is that, physically? Let's step inside the heart of it all, the server room, what a lot of people just call a data center. Welcome to the place where the internet actually lives. All this powerful gear is mounted in these big metal frames called racks. The biggest, baddest switches are often housed in a modular frame called a chassis. And to keep the thousands of cables from turning into a complete spaghetti monster, everything is neatly wired into a patch panel. You can think of it like an old-school telephone switchboard, just keeping every connection organized and easy to manage. Now, this whole system is connected by the internet's arteries, its cables. Inside the server room and in our local networks, we're mostly using copper Ethernet cables that send electrical signals. But the long-distance backbone of the internet, we're talking the connections between cities, under oceans, between countries, that's all built on fiber optic cable, which flashes data as pulses of light through tiny strands of glass at, well, the speed of light. It's incredible. So how do you actually plug a glass fiber optic cable into a big metal switch? You use one of these little guys. These are transceivers, and they are the real unsung heroes of the network. They're like universal translators. You plug one into a switch or a router, and it converts the signals so they can be sent over either copper or fiber. They're tiny, but the whole thing wouldn't work without them. So the technical name for this server room, this central hub where all the connections for a whole building or a campus come together, is the MDF, or main distribution frame. This is it. This is the physical destination our click was trying to reach all along. This is the network's central nervous system. But hold on, our journey isn't quite over. All of this amazing, high-tech equipment is completely useless without one thing: reliable power. There's an entire unseen support system that's just dedicated to making sure the lights and the data are always, always on. Have you ever had a power outage at your house, but somehow your internet stayed on? You can thank the UPS for that. An uninterruptible power supply is basically a giant battery that all the critical network gear is plugged into. So if the building's power cuts out, the UPS kicks in instantly. This is way more than just convenience. It prevents data loss and service outages. It's the ultimate safety net. And then you have this brilliant piece of engineering: Power over Ethernet, or PoE. Normally, if you wanted to install, say, a security camera, you'd need a data cable and a separate power cord, which means you need a power outlet nearby. PoE changes the game. It lets a network switch send both data and electricity down the exact same cable. One cable does it all, which makes installing things so much cleaner, cheaper, and way more flexible. It's genius. So there you have it, from a simple click inside your own computer, through a switch, out a router, past a firewall, across thousands of miles of cable to a server rack that's kept alive by a UPS. This is the hidden, physical world that powers our digital lives. And as our demand for data just continues to explode, it leaves us with one really fascinating question: what new hardware, what new kind of infrastructure will form the backbone of tomorrow's internet?
Thanks for watching.